All right, match each function with its graph. So I'm going to do a couple of things. I'm going to note some things. Notice that this says negative for number 16 and number 17, the number in front of the x squared, that a value, coefficient of the x squared, says negative. That's going to be when they point downward. So we know that, and I'll just write our possible choices here. For number 16, we've got as possible choices either C or B. Those are both opening downward. Okay, same thing for number 17. It's either C or B, just based on that. So then A or D are opening up. So we can say for 18, we can say it's either A or D, and then A or D. We've already eliminated it down to 2. Okay, that's one way that we start to identify it. Okay, now let me just repair something here. Okay, that's better. 4. Now, let's see how we can further identify it. Well, for number 17, just like for number 18, let's look at 17 and 18. I'm going to mark a couple of things on them. For 17 and 18, okay, notice that there is no x term. It just goes straight from the x squared term to the constant. Okay, the constant is going to shift things up or down, as number 17 says, plus 6. That means it's going to just shift the whole parabola up by 6 units. And 18, it's going to shift the whole parabola down by 6 units. But what it's not going to do is it's not going to shift it off of the x equals 0 axis of symmetry. Okay, the parent function has the vertex at 0, 0, and that means the axis of symmetry is running straight up and down at x equals 0. And the only thing that's going to move it off of that is going to be an x term. So for number 17, for example, number 17, and we know it's either B or C, and because there's no x term, we're not shifting left or right from the 0, x equals 0 axis of symmetry. So look at B. Okay, B has a perfectly x equals 0 axis of symmetry in it, right? Why is that? Because B matching for number 17, so I'm going to erase, it's not C or, we know that it's just simply B. Okay, it's flipped over, that's what the negative in front of x squared is, and it doesn't have an x term, so it's not shifted left or right at all. It's only shifted up or down, and so it's going to have an axis of symmetry at x equals 0, and that's what B does. Okay, now for number 16, okay, looking at number 16, we know it's C or B. Well, that's eliminated. It's got to be C. We can see that that actually is shifted off of the x equals 0 axis of symmetry. Okay, that axis of symmetry is right there, and that's not at 0. So that one does have a C term, and we're looking at that one and saying, oh, that one is then C. So we've got that down to that's C, that's B, and now let's do the same thing for the other ones. Okay, I'm going to get these axes of symmetry out of there. Let's do that same thing for 18 and 19, A or D. Well, which one doesn't have an x term? Well, 18 doesn't have an x term. Since 18 doesn't have an x term, it just goes from x squared to the constant term, that means that we're not shifted off of x equals 0 for the axis of symmetry. So we've got this axis of symmetry running right there. That is, right there for D, okay, because it doesn't have an x term, and so it's not shifted off of the x equals 0. So that is number 18. 18 is D, and the other option is A, and A does have an x term, and notice that it is shifted from x equals 0 to it's appearing to be x equals -3 or something like that. Okay? So there's multiple ways that you could have done that, but I just wanted to show you some quick tips. Now, um, you also could have used the negative b over 2a to identify exactly what the x-coordinate of the vertex is, what that axis of symmetry is, and you could then see that it's not at x equals 0 for numbers a and c. Anyway, there's a multiple ways you can do it. That's one way. Hope that makes sense to you. Um, yeah.